not give you an obtuse angle. So there are situations in which you have to use law of cosines. Yesterday we didn't give you any situation where law of cosines was needed because we gave you an angle and a side that matched up because you had 4 missing things. For law of sines, you had that proportion. You had an angle and a side, an angle and a side. So that's 4 missing things. You were given 3 of them. So for law of sines, you have to have at least an angle and its side in order to do that. If you don't have that information, then law of cosines is something you have to use. Now, it's kind of like Pythagorean theorem. A squared plus b squared equals c squared. No matter what, c squared is not always the hypotenuse. It's whatever side is across from the right angle. So same thing here. If we have a triangle ABC and C is the angle we're dealing with, then this is the side opposite the angle. So in words down here, okay, this is in letters because the letters can be whatever. The side opposite of the angle you're finding squared. So notice this is little c and this is big C, the angle. Can only take the cosine of an angle. So those will always match. If we change this, what if that was b squared? Okay, well if that was b squared, then this would be a squared plus c squared, or c squared plus a squared, that doesn't matter what order, minus 2ac cosine of b. So it changes like that. That's why the words might be easier to understand. Then you have the 2 adjacent sides squared minus 2 times the 2 adjacent sides times the cosine of that angle. Now, don't get this confused with the area of a non-right triangle. We're not finding the area. Now we will. We'll bring that back up at the end of this unit when we start our navigation problems on next week, Tuesday, Thursday. But for right now, you have law of sines and law of cosines. But that area is going to come back in, and you can't get confused with the area versus the law of cosines. Law of sines, use sine. Law of cosines, use cosine.
Are you always going to do right triangles or no?
Probably never.
Okay.
So it was right triangle, a squared plus b squared equals c squared.
Yeah.
Right? Okay, so if we're looking for sides of a right triangle, we can use a squared plus b squared equals c squared. This is for, okay, we're not in the world of everything's right anymore, and we've got to have more things and laws and formulas to use to find that. And then down here I just made up another, FGH. Doesn't have to be ABC, FGH. Just notice that the h squared and the h, the f squared and the f right there, those will always match. The outside, whatever you're squaring equals, and the cosine of that side, whatever you're squaring, is going to match that angle. Whenever you're labeling a triangle, your angle F has to be across from side F, or your angle C has to be across from side C. That's how you do that if it's labeled. Like sometimes, like this first problem that we do, it just says, give the 3 angles. So you can name it whatever you want. You don't have to name it. It is up to you because it's not very specific in A equals this, B equals this. It just says here are the sides, find the angles. All right, so law of cosines, that's what we're going to use today, in addition to a little bit of law of sines as well. All right, so this first one, it tells you that 2 sides of a triangle have lengths 3 and 7. The angle between them is 130. Unit 3, what is the area? This is not asking for the area. It is find the length of the third side. So this exact same problem could say find the area, could say find the length of the third side. This is the length of the third side. So I'm going to draw it. You don't have to, but I am, because the drawing is always helpful. So there's a 130-degree angle. Let's say this is 3 and that's 7. How do I know to label those 2 sides 3 and 7? Lengths 3, 7, and the angle between them. That's how I know. I read the problem. Okay, you can't just make up your own triangle. You have to use the triangle that is given. So the angle between those 2 sides. Now, if you put those 2 sides at the bottom, the top and the left, the bottom and the right, like wherever you put them, it doesn't matter. It's just they have to be on either side of the 130-degree angle. And then I'm going to call that x. Now, yesterday, law of sines, but you don't have enough information for law of sines. You have an angle, but you don't have its side. You have a side, no angle, a side, no angle. So you don't have enough information. Side, angle, side. Remember all those S's and A's from geometry? They're coming back a little bit. So for side, angle, side, you have to use law of cosines because there's not enough information. All right, so we're going to take the side across from the angle and square it. Equals one of the adjacent sides. Doesn't matter if you use 3 or 7. 3 squared, because then you have to do the other one. 7 squared minus 2 times 3 times 7, or times 7 times 3. 3 times 7 is 21. 7 times 3 is 21. Doesn't matter which order you do that in. Times the cosine of the angle across from the side that we're looking for right there. Now, this is the easiest one there is, because that x is already all by itself on the other side. When we're looking for the angle, not quite as easy. We can type that in just like that. That would be the work. This would be the work I would expect to see. After that, everything you can do in your calculator. Now, we're dealing with a triangle, so we're going to be in degree mode. So we clear your calculator. Be sure you either put it in degree right now or it's in degree. And we can just type that in exactly as it's written. 3 squared plus 7 squared minus 2 times 3 times 7, cosine of 130. That is not your answer. Let's think about it logically. If one side's 3 and one side's 7, it doesn't even make sense that one side could be 84. That's what x squared equals. So we have to take the square root of that, and there is your answer. 9.219, and centimeters were given, so we must use the correct units. So again, side, angle, side, easiest one for law of cosines you could have. Just don't forget to take the square root. And because these are all calculator problems, it could be very, very easy to make a mistake. Take your time and be careful typing it into the calculator, because what you type in the calculator, I have no idea. What you write versus what you type in the calculator needs to be the same, so just be sure and take your time. Yep?
So how does the law of sines for this one, how is there not enough information?
Okay, so if I was trying to do law of sine, all right, the next one gives us 3 sides of a triangle. We want to find the 3 angles. Now, we have no idea if any of those are obtuse. There's one that could be obtuse. The side across from the 12 might be obtuse, but it doesn't have to be. Okay, you can have a triangle without an obtuse angle. But because this one has the possibility of being obtuse, we always want to find that one first. It is not necessary. It's just the easiest, because then once you find the angle across from the 12, the angle across from the 10 and the 5 have no chance of being obtuse. And so then you can use law of sines, because you're going to have to use 2 laws, either 2 law of cosines or a law of cosine and then a sine. So I'm going to draw this as if that angle across from the 12 is obtuse. It might or might not be. I don't know. I'm going to say this is 12, 10, and 5. How you draw your triangle does not matter. You don't have to have one, but I'll tell you it's going to be a lot more helpful if you do. All right, so you can find whatever angle you want first. I am going to call this angle A. You can call it whatever you want. You don't even have to call it anything. You have to call it something in your problem. You can say theta. It doesn't matter because it's not named in the problem. Whatever you want it to be. Again, the reason I'm finding A first, because it's across from the biggest angle, doesn't matter. You can find whichever one you want first. But if I find A first, then I know these other angles don't have a chance of being obtuse because it is across from a smaller side, and you can't have 2 obtuse angles. And let's say A was 80 degrees. If A is 80 degrees, there's no way for 10 to be more than 80, or the 5 to be more than 80, because they're smaller than the 12. Okay? All right, so side across from the angle squared equals adjacent side squared plus other adjacent side squared. 2 minus 2 times each adjacent side times the cosine. I named it A, theta, alpha, x, whatever you want. Doesn't matter. It is not named in the problem, so you can name it whatever you want. That is the work that I would expect to see. Now, some of you can do this in your calculator, but I can tell you, last class, every class there's a lot of erasing going on because a lot of you forget about the algebra part of it. Simple math. I'm going to do a little bit more work on this one. 144 equals 25 plus 100 minus 100 times the cosine of A. So is that right side? 144 equals 25? Do those hundreds cancel? So 100 minus 100 times cosine A. See, that's the biggest mistake made right there. Okay? Those do not cancel. It's like saying 5 minus 2x equals 3x. We all know that's not true. Okay? None of you would tell me that. Not one of you, I know. But now we add trig in it. It's no different. This cosine A is some number. So this is 144 equals 125 minus 100 times cosine A. These are not like terms, so we can't combine them. But we do need to bring this 125 over. So 19 equals negative 100 cosine A. Divide by negative 100. And now we can say the inverse cosine of negative 19 over 100 is going to give us our A value. So all that work I did is not necessary. Okay, this part right here is, oh no, just kidding. This right here isn't necessary. This right here is what I'm looking for. That is the most important part. This is not bad. This is good work to show, but not necessary. All right, so inverse cosine of negative 19 over 100. Be sure to use the negative sign, not the minus sign. You get your first angle, which does happen to be obtuse. Doesn't matter if it's obtuse or not. Hopefully we kind of have an idea that it would have been obtuse because the inverse cosine of a negative number, that's quadrant 1 or 2. Cosine is negative. The side is negative in quadrant 2, but the angle is just obtuse over there. So our first answer is 100.953 degrees. Now my calculator, yes?
So when you get that, like let's say you labeled angle A, angle C, it doesn't matter because
Nope.
you're just finding.
You're just finding that because on this one. Now, if it had said little a equals 12, little b equals 10, little c equals, then it would matter which angle is which. But on this one, it just says find the 3. So you don't even have to have them. You can have them labeled as whatever. Okay? Now, my calculator doesn't let me scroll up and grab it, so I'm going to store that and just make myself a little note right here that I have that angle stored as A because I'm going to need to use that in order to find that. So I still don't have enough information just to add and subtract. Now I need to find one more angle using either law of sines or cosines. Now, after yesterday, hopefully you'll notice that law of sines is a lot easier than cosine. Okay? It takes a lot less time. It's just the proportion. So what I would do on this one, because now I know, I'm going to call this B and this C. I know angle B and C have to be acute because I can't have two obtuse angles in a triangle and it exists, which Monday we'll get to triangles that don't exist. Right now everything's going to exist. All right, so I'm going to use law of sines now because there's no chance that C or B can be obtuse, so it's okay for me to do that. So sine of that 100-degree angle, not 100 degrees, that whole angle, don't round, never type in rounded answers ever into your calculator, over its side, which is 12. Let's do sine of B, or C, it doesn't matter, B over 5. If you did C, it would just be over 10. Either one, it doesn't matter which one you find. All right, so that is the second step of work I would expect to see. Some of you might need to show a little bit more work from there, some of you don't. So now I cross multiply 5 times the sine of that whole number right there. Again, I had to store mine as A, divided by 12. That gives me what sine of B equals. I want to know what B equals, so second sine of that number. There's your other number, 24.146. 7 degrees. Now, I have 2 of the 3 angles in a triangle. So 180 minus that 100, which I stored as A, plus that 24 number, gives you what's left. 54.9. If you want to put 0, 0, you can. You don't have to put the 0, 0. Always rounding to the thousands. But again, you do not have to put the 0, 0 if you don't want to right there. And because they weren't named in the problem, we don't have to specify which ones were A, B, and C. It just said list the 3 angles. If they were named, each angle would be very specific. The biggest angle has to be across from the biggest side, the middle from the middle, the smallest from the smallest. So law of cosine is not difficult, just takes a little bit longer than law of sines. All right, last one here in the diagram. So it gives us a diagram and it gives us a bunch of lengths. So it tells us AB is 5, tells us BD is 2, DC is 4, so that means this whole thing is 6, which we're going to need to use. And CA is 7. We want to find AD. Okay, well, I'm going to rename AD as, I'm going to call that X. So it's just easier, so I don't have a bunch of 2 letters. You don't have to. You can keep it AD. You can name it B. You can name it C. You can name it whatever you want, because you only have one answer, so it doesn't matter. Now, I don't have enough information to just do one step. Like if I take this little triangle, I have side, 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 but I don't know that side, so I really don't have enough information. So I have to take that big triangle, 5, 7, and 6, and find either angle B or angle C. It doesn't matter which one you do. B and C are not going to be equal because one has a 5 across from it, one has a 7, but your final answer is going to be the same. I'm going to find angle B. So I'm going to find this angle, because it's across from that side. This angle is across. They're both across from X, but you just have to pick one. It doesn't matter which one. All right, so if angle B is what I'm looking for, 7 is across from that, so 7 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of B. Same problem as a second ago. If you want to do a little bit more work, 49 equals 25 plus 36 minus 60 cosine of B. I don't have to see all that work. It's just up to you if you want to do that. If you do it in your calculator, that's fine also. So this, what is that, 50, 61. So when I subtract 61 over here, I get negative 12 equals negative 60 cosine of B. Divide by negative 60. 0.2 equals the cosine of B, or 1/5, or you could just leave it negative 12 over negative 60. You don't even have to do all that in your calculator. What we do have to find out is second cosine of 0.2. Notice it is positive. It is very important that it is positive and not negative. Negative divided by negative gives you a positive. So we found angle B to be 78. So that 78 number, I'm going to store that as B because I'm going to need to use that in a second. Again, I'm just storing because my calculator doesn't allow me to scroll up and grab it like most of yours do. All right, so now back to this triangle right here. So if I want to find this X right here, I know this is 2 and this is 5, and now I know this is 78 something. So now I have enough information to find that side across from the angle that's missing. But I have to use law of cosines because I still don't have enough information to use law of sines. So x squared equals each adjacent side squared minus 2 times each adjacent side, bless you, cosine of that entire number. Never ever type in rounded answers into your calculator. Ever, ever, ever. Only round at the very end. So when you type all that in, you should get just 25. So your final answer is 5. Now that looks like, oh, we could have done that without a calculator. You absolutely could not have done the cosine of 78.46304097 in your calculator. That is not a problem that could have been done at all without a calculator. Always have to use it. The only ones you can do without a calculator is if